Basically, I will introduce a bit myself, my personal background. Basically, I'm from Spain. I'm from the south, from Malaga concretely. I was working with my telematic engineering degree in the University of Malaga in my hometown. Also my master's degree in telematics engineering. And currently I am in Aalborg University, and my supervisor is Elizabeth de Carvalho. And as you can see, there is this flight with a strike on France because we are flying around United Kingdom to Denmark, but it's okay. Basically, my main topic is about working with large intelligent surfaces for sensing. One of the main advantages, let's say, for communications in 5G networks has been the usage of multiple antennas of massive MIMO technology in order to increase the spectral efficiency. And basically, the next, let's say, a step further away is why don't we use also the sensing feature to exploit some optimization in the communication. Basically, the large intelligent surface is a concept that is kind of a state of the art. Basically, it could be seen as a continuous electromagnetic surface which is able to transmit and receive wireless signals in a controlling manner. Basically, they are easily integrable into walls, so they could be placed around a room, for example. And we could define them as a collection of closely spaced tiny antenna elements, basically. Our main target is basically sensing, so the question is, can we reduce the complexity of knowing what's going on in the environment by representing that information as an image? That's what we try with try to provide a high resolution image of the environment. And if we are able, for example, to track the user, maybe we could perform some wireless optimization like beamforming. Here I have described kind of a use case of the large intelligent surface. We can see that the access point is trying to communicate with the user, and basically the direct path between them is blocked, so the signal-to-noise ratio is really bad. And this surface is smart enough, let's say, to reconfigure its antenna elements to beamform towards the user and solve this communication problem, basically. And so our main goal is generating these images. For that, we are using our ray tracing software now to generate the samples and see how it goes. And we are working on 3 approaches for sensing, basically. The first of them is taking advantage of the communication signals that are occurring within an environment. So we can see here in the image that these 2 women, for example, they are using their phones, and the signal are traveling through the air and impinging into the obstacles. So some disturbances are generated in the wall image, according to the large intelligent surface. And basically, 2 more approaches that we also want to work on, although I am currently working in the first one. It's the tomography-like and the radar-like. Basically, the tomography-like is we could divide these large intelligent surfaces into sections that can transmit one after another, so the rest will be measuring and receiving the signal strength. So somehow we are scanning, let's say, the environment, and the radar-like, it will be similar to the tomographic-like, but we will be using a dedicated signal pointing towards the target user that we want to sense. And in order also to analyze let's say, this technology, where I am proposing a use case in an Industry 4.0 scenario. So basically, in the ray tracing software, we have a fixed scenario, a fixed small industrial scenario, in which we can see that there are several, let's say, robots, obstacles that are in fixed positions, and also some obstacles that are blocking the line of sight with the surface in the bottom of the wall. And then the red the robot highlighted, is defining a predefined route horizontally. So basically, we are trying to see if, according to the holographic images that we get for describing the environment, are we able to detect if this robot is following its predefined route, or it has some anomaly. Maybe it fell, or maybe it went a step further, or whatever. And for doing that, we are taking advantage of some transfer learning techniques and those stuff, but I don't have time to explain it further. Sorry for that. And actually, my current status, let's say that we are working on analyzing the potential of this technology, basically analyzing the aperture, how much important is having that many antenna elements. Also, some image processing techniques could be applied to these images, maybe some FFTs to see what's the important information focus on. And also, right now we are working on a conference paper entitled as Radio Sensor with Large Intelligent Surfaces for 6G, which is going to try to be published, well, I try to submit it to the International Symposium on Wireless Communications.